Hi there, I'm Hao, and this is just another video of me solving random liquid problem. So we have word search 2. So I suggest you to do word search first before doing this problem. So word search 1 is problem from 79, and you should be familiar with try, right? And problem 208, where you implement a try, and how how it works. So the redirect is that you should do 79 and be familiar with try. Right. So word search 2, right? So we are still given an m by m matrix um of characters with a list of string word, return all words on the board. Right, this is the same picture in the word search 1. Each word will be constructed of letters sequentially adjacent cell, right? Horizontal and vertical neighboring, so 4 neighbors. The same program may be used on one word more than once in a word. So previously, like we only check if a word exists, right? And to do that, we need to run the DFS, right, on each cell, right? And to run the DFS on each cell, and they have 4 neighbors, right? So each DFS gonna cost us 4 to the side of the board, right, which is m by m, right? And this is the time complexity for one DFS, and we need to run it for every single cell, right? That is n by n, right? So that is our time complexity. If we check if a word exists, right? And then now, we need to check to see if a list of word exists, right? We have an array of word here, right? And we need to return an array of word that exists. So that is, let's say W is the number of words we have to run, right? We need to check. So this is our total time complexity, right? If we reuse our previous solution, it's pretty straightforward, right? Because we just have to have another loop for every single word, and then add the word in the resulting array, if that exists, right? So doing so will not let us pass the large test case. So the goal that we are trying to do is that we're trying to optimize for the W here. We want to reduce our time complexity to the, and then how can we do this? Um, the hint I suggest that we can use a try to do this. So instead of running a DFS, or every single time, right? For every single cell, for every single word, right? We can check if every single word exists, right? By running the DFS on only on each cell, right? And to do that, we need a try. We need to store the word in the try, right? So let's say we have OAuth, right? OAuth, and then the next one gonna be PEA, and then EAT, right? And then RAIN, RAIN, right? Right. Let's say we also have like dog, right? And then at the end of the word, right, we're gonna have a flag to indicate that it is end of word, assuming you're already familiar with the try, right? And the try, right, is a prefix tree, which is it can use the same letter to store the word, right? It have the same prefix, right? So let's say I also have dogs, right? So in this branch, right, I have dog and dog, right? So the thing is, if you store the word, every single word, right, in the word array, in the try first, then when you run the DFS on each cell, you can use a try to run a DFS, right? So for example, like O, right? You can check if we have an O in the try, right? And then just keep going like that. right? Right. So we will have to keep track of the current node, right? Of the try, right? So if we try zero here, right? It has two child, right? A and E. So we try E first, right? We try E, right? We try E, and then E doesn't exist, right? Because O only have one children, right? Which is A, right? So that doesn't work, right? So we go back and try A, right? And now we have A, so we move on to the next node, right? Then A have two child, A and T, right? So we just repeat and do the same thing, right? And we have to keep track of the uh, visited node, right? Because we cannot use the same letter twice in a word. So when we visited a node, we can mark this, right, at like no, right, or whatever it is. So if this doesn't work out, we can go back and then send it back to E, right, to the previous letter. Okay, so using the try, we can find every single possible word by running the DFS on each of the cell, right? So if we found a word, right, DOG, for example, right, we're gonna add the DOG into our resulting array, right? Let's say dog this, but we're not gonna return here, right? We have to keep going, right? If the board gonna have like something like this, right? DOGF, right? We're gonna find a word dog here, right? We're gonna add it to our array, but we're not gonna return, right? Because we want to find every single word, so we need to keep going. Right? If we find the word dogs, so we add the dog and dogs, right, into our resulting arrays. So yeah, uh, that's pretty much the whole trick here is to use the try to optimize for the W, right? And a try gonna have a we need a try node, right? It's gonna have a children array. Sorry, the children hash map. Even though we only have lowercase English characters here, but I want it to be more dynamic to work on anything, right? So I use a hash map of the children or the children hash map here, and then it's gonna have the the flag, right, to indicate if it is an end word or not. Yeah, so well, we need a try node and a constructor, right? In the try node, and we also need a an insert function, right, so that we can insert into our try. So yeah, let's code this up. All right, so first thing first, we can relay our try, right? Need a try node, right? And then we need a constructor. We can type in the words array. E for us m at empty, so we do const word on word. We can insert it into uh, our try, our insert function, of course, by typing in a word, right? So we need a so this is a default. We can take in a word array, right? It's just a nicer interface, right? Where I don't need to call like the insert again when we do when we are in the file word. So we provide a very nice interface here. So we can add all the word initially when we create a try. We have a children abstract, right? And then we need to flag okay, if it is a end of word or not. And it is default to be false. Okay, so how do we insert the word? So we need to set the current equal to this, right? So our try, right? Our try gonna equal to a new right try node, right? This is what we are trying to do. Try node passing in the word array, right? Try node, right? We're passing in the word, and then we can add it into our try, right? In the constructor, and then the first try node, right? It's just a dummy node, right? And the second letter will not start until the second note, right? So so for example, this the children, right, of O, right, will be our the O will be the letter O. For example, in the O of word will be in our the first letter will be in our children, right? In the first dummy note, in the dummy note. Okay. So we just have to iterate over every letter in the word. Right, so I guess I can do the for of loop here for jar in word or jar in word, or we can do jar exists, right? Jar. Okay. So we need to see if it is exists, right? If the chart doesn't exist, then we need to create, right? Cur.children, right, of char. Right. So if char is not in the hash map, in the children hash map, we need to create a new char node for it. Then we just move on to the next node, right? Okay. And at the end, we can set the end of word to be fixed. So we iterate over every characters in the word. If it exists, if it doesn't exist, right, we create a new try node for it and then move on to the next one. Okay, so that's it for our try. So now we need to create our constant here, the row and a column. Right? Our try, we need our resulting arrays as well. Right? And we can return it at the end. Okay, so we need to run the DFS on every single cell, right? Okay, then we can run DFS on every row and column. And then we need to type in the try, right, which is the current node. Yeah, we need to keep track of the current node, right? Our try node not gonna have a search function, right? Because we are combining it. We are searching it in the try, right? By keeping track of the current node. And we have to fill out the word, so we can start out with an empty string. So this is the current node and the word. So when do we return? So if um, not inbound, right? If it's not inbound, or if it is the letter, right, is not found, we can return it. So not inbound is equal to row is less than zero, right? Or column less than zero, or row is greater than or equal to row, or column is greater than or equal to column. And then letters not found will be equal to if the letter but is not in the node structure, right? And the letters is gonna be like the current letter at the row and the column, right? If it is inbound. If it is not inbound, then we just have an empty string here as a placeholder. Okay, so if the letter not found means the letter is not in the node of children, right? If it is not found or it is not inbound, then we want to return. All right. Otherwise, we need to move to the next node, right? letter in this case. Need to add the letter to the word because we are building out the word, right? So remember that we are checking before we even moving to the next note here because our first letter, right? The first note is just the try note, right? The first note is just a dummy note. Our first letter won't start until the second note, right? So this is gonna be like the letter O for O off, okay? So if the note is end of word, right, which means that we found a word, so you can uh push it into our O word, push the word, right? And then we need to avoid duplicate, right? Right. So for example, right, uh the word dog, right, can be get from top to bottom, right, or from left to right, right? And then chi will be the end of word, right? So if we already found the word, right, and we want to set the end of word to be false to avoid duplicate, right? So note on end of word to be false, okay? So and now we just have to keep going, right? Right. So if it is inbound, right, and the letter is found in the children, right? So we add that letter, keep it our current word, and move on to the next note, right? So now where are we going? We have to go in four direction, right? And then we need to set the board at row and column, right? And set it back, right, to be the letter, right? We need because each letter can only be used once in each word in the word, right? So we need to make sure that we mark it to be no when we try out the neighbors. Okay, row and column, having the note in the word, right? In the word, um, the note in the word is already being updated, right? The word having the next letter, right? And the note is moving on to the next note. So okay, we need to go in further direction. But this is plus one, and this would be for the column minus one. Yeah, I think yeah, that's pretty much it. Yeah, so we have our constant here. We add all the word to the try at the beginning, right? We done a DFS on each and every single cell, right? If it is not inbound or letter not found, we return. Otherwise, we go to the next node and then add the letter. If it is end of word, we push in the word, right, and keep going. Set the end of word to be false so we don't have duplicate, right? We keep going because we may have the other word, right? Like for example, dog and then dogs. So we need to avoid duplicate, right? Avoid a letter to be used twice. So we set the current letter to be no, and then set it back later on. So let's give it a try. Okay. So somehow it's just not showing anything here. Let's just making sure we are correctly looking through. Okay, why are they all numbers? So I guess I just have to use a normal only work for array, I think. Okay, let's start again. Okay. So I just incorrect use of the for loop here. Right. So let's submit that. Okay, and it worked. Thank you for watching.